Good morning, grade class. My name is Ilana Duplessis, and I will be your tutor for today. So, today we are focusing solely on algebra, which will be your question one of your grade 12 paper one mathematics. And then we will be looking at functions that will be done tomorrow. So, if we look, I'm going to share my screen with you. The the PowerPoint so you can see also what is specifically what we are going to be doing. So if I go, I'm sure you can see my screen now. If I go here, you can see that today it will be algebra, like I said numerous times now. So if I look at specific outlines, we are looking at 25 marks, which is normally a question one, plus minus. The types of question that we are doing, it will be solving equations using factorization. We've got solving equations using the quadratic formula and inequalities, as well as equations of surds, exponential equations, and simultaneous equations. So it's important for me that we look at each of these type of questions, because this would be normally your routine type of questions where um, it is expected that you at least must get these questions right and that we can obtain a good mark within the algebra section, because later in the paper you might find questions that are more challenging, and we would want to make sure that you receive the routine marks as well. So we are going to be doing the following today. I'm going to give you 20 minutes to complete question one. So the thing is, I want you to do question one first, so that we can see what is your efforts, what are you doing once this type of question is being given to you. So, and then I will be going through that question with you, going slowly, explaining to you what is the nice tips, what must you look out for, that type of things. And then once that is done, I will give you another question that is exactly like this type of question, very similar, that you can see what is it that I must look out for. Once I see this type of thing, I know I need to do the following. So that is our goal for the day. So I'm going to start the timer now. You have 20 minutes, grade 12s, to complete question one. So you'll see there's a line through 1.3. Please do not do 1.3. That is a problem solving, and we're not going to focus on problem solving today. So only 1.1, the entire 1.1 and 1.2. Then I will speak to you again in 20 minutes. Good luck. All right, great, Charles. So we are going to be marking that. Let's go through them together. If we look at question 1.1.1, we can see that we have a quadratic equation, right? So one of the first rules that we have for a quadratic equation is the fact that if it has x to the power of 2, then that is our guide to know that there's going to be two answers for x, right? The highest exponent was 2, so that means there's going to be two answers. And the second thing that we need to look at the fact that there is a 0. Because it's a quadratic equation, it must equal to 0. So, which means that we cannot be just taking the 6x over and say, well, this is now how I'm going to go about. We have to keep everything to the left-hand side, or whether it be the right-hand side, but it has to equate to 0. Which means now I'm going to have to factorize. We have to take out a common factor of x, which leaves me with x minus equal to 0. Then I know what I'm going to do further will be x is equal to 0. Or you can say x minus 6 is equal to 0. You do not have to show me this step. You can then straight go to x is equal to 6. So you can see that we had two answers for x. Then grade 12, we had question 1.1.2, which was x squared plus 10x plus 8 is equal to 0. Then two things that I would like to say here is, one thing, very importantly, that you look here, it says correct to two decimal places. Because it says correct to two decimal places, that there is your guide. That tells you that you are not going to be bothering but trying to factorize this the trinomial. You are going to go straight to the formula. And what formula am I referring to? The first one on your formula page would be minus b plus minus square root b squared minus 4ac over 2a. So that would be my first thought there. Because I saw that it says correct to two decimal places, I'm now going to jump into the formula. We do not have to write down the formula. We can just simply go and substitute. You have to show the substitution. You will receive a mark for it. So minus 10 plus minus, then it will be 10 squared minus 4. A is 1 and C is 8. My apologies, I still wanted to show you for those that are wondering where did I get this information from, because look, you're revising. It's stuff that you have now haven't done in quite a while, so where do I get this stuff from? You look here in front of this is a 1, so that is invisible 1, which means A would be 1. 10 with its sign, it's a positive 10, would be B, and with its sign it will be C, that is 8. That is where I received the values for A, B, and C. So once I've typed this into my calculator, then I will have x is equal to negative 0.88 rounded to 2 decimal places, or we will have x is equal to negative 9.12. Right, so then I move on to my next question, which is 1.1.3. I've got 1 minus x and x plus 2 smaller than 0. So this is the inequality. Now, very importantly, the inequality looks different, and there's a reason why it looks different. This part here, that is the part that is bugging you. And it's supposed to bug you, and you should let it bug you, because you cannot just leave it there and go on as per normal with your normal inequalities. It has to say x minus 1. It has to be the other way around. But then how can I all of a sudden swap this around and let it say x minus 1? What is the change that I need to do in order for us to literally swap those two things around? I have to take out a negative as a common factor. So I put a minus in front. But now I cannot do inequalities with a minus that is in front there. So that minus needs to be divided throughout. So I will end up with x minus 1, x plus 2, but the effect that I learned in grade 10, once I divide with a negative through my inequality, that thing will swap around and it will become a greater than 0. My next step by inequalities is that I now have to go and draw my number line that shows my critical values. My critical values I get from here. The critical value for this specific one would be x must be 1, and then it will become 0. So that is how I choose my critical values. This one's critical value will be negative 2. So I will write negative 2 and then positive 1. Why do I write it this way around? It's because we need to keep in mind that this is a number line and it needs to be in order. Negative 2 comes before 1. So next I will create my parabola. And now I have to go back to my question. My question is asking me, where is this thing, the function or the equation, greater than 0? So for greater than 0, I'm actually referring to positive, which means my y values must be positive. And where is my y values positive? It is positive here and here. And if I look at that carefully, then it means that I'm going to look at the x values that are going to the left-hand side of negative 2 and to the right-hand side of 1. So how do I write that in a proper form? We have two ways, two notations that we can use. We have inequality notation and we have interval notation. So inequality notation would be that I have x that is smaller than negative 2. And am I going to use to help you? And obviously I said I'm going to give you tips for success. My advice to you is, because you see the arrow going that way, your arrow also needs to be going that way. You know this is smaller than sign. Or x greater than 1, and you can see again your arrow is pointing to the right, my arrow is pointing to the right. So I either do this, where this is inequality notation, or I can write in interval notation where I write x as an element, but I prefer not to write in interval notation because it's more difficult. But I know that there are a lot of learners that only use the interval notation. So when I have to write this specific answer in interval notation, means we are going to come from negative infinity to negative 2. So that means from negative infinity to negative 2. Right, but now I need to look at my brackets. If I'm going to be at infinity, it will always be a round bracket because we do not know where infinity lies. But if I look at negative 2, my apologies, if I look at negative 2, Then we must look at the inequality sign. Was that included? Was that also equal to 0? So it wasn't. And if it was, it would have had a line underneath. So that was strictly greater than 0, which means it wasn't equal to 0, which means I can't be equal here at this specific point, which means I cannot include my -2. So that will also be a round bracket. Or now we're doing the other side. That will then be from 1 to positive infinity. Again, round brackets. Same reason, can't include 1 because it wasn't included and we don't know when infinity lies. Then we look at question 1.1.4. Also a very familiar question. We are used to this type of questions. Like I said, this is the typical stuff that you will find in question 1. And it's important that we master this already. So now I've got a square root that is, or surd that is bugging me in this situation. So how do I get rid of the surd? I need to obviously do the inverse of square root, which is then square. But what I do on the one side, I need to do on the other side. Right? So that leaves me with these two cancelling each other out, gives me x plus 18. But now what do I do on the right-hand side? Yeah, I need to now check. A lot of us already knows how to get to the answer straight, right? Which will be x squared, because we square the first one. Then we say x times -2 is -2x, but times by 2 gives me -4x, and then plus 4. If you're unable to go there straight, then it will be your call to do the following. On a side somewhere, even on the question paper itself, you can just quickly go and do your FOIL method, where you multiply out your brackets and you get x squared minus 2x minus 2x plus 4. They are similar, and then -4x plus 4. So then you can just slot it into the question. But that is if you are still struggling. And there's no problem with that. You still have that option. Here on, I'm again seeing that I've got x to the power of 2, which means I'm still sitting with a quadratic equation. And what did we learn? If it is a quadratic equation, we know that it must equate to 0, which means that I will have 0 is equal to x squared. And now it means that I cannot have these values here. So I need to get rid of this x, which means I will subtract x on the left-hand side. If I do it on the left-hand side, I must also do it on the right-hand side. Or in plain Jane, you will just say you're taking it to the other side. But we know that's not mathematically correct. So that means once this goes over, it becomes -x, which gives me -5x now. And then I also had 4 minus 18 gives me -14. Now the question is, how do I go further from here? This is my trinomial. I need to now look at my factors. How do I get 14? The factors of 14 will be 7 and 2. Signs are different, biggest one negative. Now, it is not my job today to teach you how to do trinomials. I'm assuming you guys are all masters of trinomials already. If you are not, then it is your job to make sure that you go and you practice your trinomials. This thing gives me x minus 7 and x plus 2. And from here on, we're back to the same type of question by question 1. We are going to say x will then be 7 or x will be -2. Now, this is where I also need to say something specifically. By this question, I'm going to have to test my answers. Why? Because initially I had x to the power of 1, x to the power of 1. I did not have x to the power of 2. It was our fault that we have x to the power of 2 because we squared it. We chose to square it. So yeah, I'm not supposed to have two answers. I'm going to have to go and test each one. So what I'm going to do is I'm going to say square root 7 plus 18. That gives me 5. And if I say 7 minus 2, I still get 5. So both of them are the same. So that one is definitely correct. So now I'm going to try the other one. And I'm going to show this one actually to you. if I have square root, negative 2 plus 18, and on this side, negative 2, negative 2. This gives me square root 16, and square root 16 is 4. On this side, I have negative 4. Are those two things the same? I know the 4s look the same, but they are not the same. Positive 4 and negative 4 are two different things, which means that this one cannot work. And if it doesn't work, then we draw a line through it, or we say not applicable. Right? We can use that as well. So it will only be the second. Next question. We're looking at question 1.2. So 1.2 is our simultaneous equations. So we have x plus y is equal to 3. That is my linear equation that I have. And then we know from grade 11 now, we have a linear and we have a quadratic equation. That is why we can only use substitution in this method. We cannot use elimination that we learned in grade 10. So here, I need to decide which one, either the x or the y, I'm going to make the subject so that I can go and substitute the answer into the bigger equation, which is the quadratic. So I'm deciding to keep the y, and I'm going to move this x over, and I'm going to say y will then be 3 minus x, which means every single time I see a y, I know it is equal to 3 minus x. And I will replace the y here, and I will replace the y there, which leaves me with 2x squared plus 4x, and instead of writing y, I will write 3 minus x. Minus, and instead of writing y, again 3 minus x. Important, I need to make a substitution inside brackets, because there's a lot of learners that do not put this next one in a bracket, and then they make a sign error, because you're supposed to, you'll see now when I multiply it out, you will see what I mean. And hopefully you did not make that mistake, and hopefully yours is correct. But otherwise, if you did, you can see why I say rather always substitute within brackets. So when I multiply this out, I will have 12x. I will have negative 4x squared, multiply negative 3. And this is where I'm assuming errors came in. A negative and a negative make positive x is equal to 15. Right, now if I look and I analyze my question, my answer, I see I've got x squared, which tells me this is a quadratic equation. And again, I want to equate it to 0. So everything must be on my left-hand side. I'm also going to put my similar values together. My like terms, that's the word I was looking for, my apologies. 2x squared minus 4x squared gives me negative 2x squared. 12x plus x gives me 13x. And then I have minus 3 plus I also need to carry this one over. It's minus 15, which means it's negative 18 is equal to 0. Then if I want to factorize my trinomial, I cannot factorize with a negative, which means I'm going to have to divide with a negative 1 throughout, which only changes the signs of my terms. So that becomes a negative 13x and a positive 18. So now I must look for factors. My factors will be there. The factors of 2 is 2 and 1. The factors of 18 is 9 and 2. It's definitely this route. But now the signs are the same, both negative. So if I do this and I cross multiply to test and see if my factors are correct, because it cannot be the other way around, I will have negative 4 and negative 9, which gives me negative 13. And that corresponds with that. Again, this is something that you should have learned in grade 10 using your trinomials, or even prior, like grade 9 already, actually. So my factors will then be 2x minus 9 and x minus 2 is equal to 0. And here my answers for x will be 9 over 2, or it will be x is equal to 2. And a lot of learners stop here. but you must actually just go back to the question. The question didn't say solve for x that we are normally used to. It says solve for x and y, which means that you still need to go and find the y value. You need to go and replace this x value back into either one of these or this one, but I wouldn't suggest that. I would definitely suggest the smaller one. You need to go and put this x value back into the smaller equation to get the specific y value. But very importantly, use this one because you've already made y the subject. So I will say y is equal to 3 minus 9 over 2. Y is equal to 3 minus 2. We can see this one is 1. And the answer for this one will be negative 3 over 2. That is what I got. Okay. So hopefully now, grade 12, you've seen how I do the sums, and hopefully you fixed your errors, and then you also put on some few tips. So now what I want you to do is I'm going to go back to the PowerPoint. I'm going to go to question 2, and I want you to see the following, right? You've got question 2, that goes 2.1, 2.1, and then also 2.2 and 2.3. I do not want you to do 2.4. That is why there's a line drawn through it. Another thing that I want to mention by question 2, 2.1.4. On your notes, it says x minus 7 square root x minus 12. But there's an error. You need to adjust and you need to change that question. You need to include, after the square root x, you need to include an equal sign, which is then equal to negative 12. So please make sure I fix it on the PowerPoint. That's why it's in red. I just need you to go, fix that mistake and then use the right question. Otherwise, you're going to struggle. So you, grade 12, now have 20 minutes to complete the following questions. After 20 minutes, I will then go through those questions answers again. Good luck. All right, grade 12s. So we are going to mark our first question of question 2.1.1. In this question, we didn't have to factorize. It was already factorized, so that's a straightforward one. We know we're going to take each factor, set it equal to 0. So that would be 3x. You take it 6 over, will be equal to 6. And x is equal to 2. Or x will be equal to -2. You do not have to show me this step. We're getting to 2.1.2. Yeah, I've got 2x squared minus 6x plus 1 is equal to 0. Again, it says on the questions, correct to 2 decimal places. Because they say correct to 2 decimal places, we know we're not going to bother with the factors. We are going to straight into substitution into the formula. Minus b, so minus -6 plus minus square root b squared minus 4ac over 2a. Once I substitute that in, we get the answers of 2,82 or 0,18. Right? Then question 2.1.3. I think that was pretty straightforward up to this point. We've got x squared minus 90 greater than x. So looking at this, it's a quadratic equation. Even though it's an inequality, it's still quadratic. We know from our rules from quadratic equation, it must equal to 0. So x squared minus x minus 90 greater than 0. So something that I want to mention here is I'm going to have to factorize for this specific one. We do have the factors of 90. If you're starting to factorize this, then you can use the formula, but you're going to have to end up with your brackets. So, or alternatively, you still need to use your number line. So the factors would be 9 and 10. So it will be x plus 9 and x minus 10. That will give me -1 greater than 0. After that, go to my number line. Put in our critical values. Our critical values will be -9 and +10. Draw my parabola. And then next what I will do is I'll ask myself, what is this question asking me? I want greater than, which means I'm looking for positive. Because I'm looking for positive, then it means that I'm going to be needing, where is my y values positive? It will be here and here. Again, very similar to what we had earlier on. So from here going outwards, which means that I can now say the answers will be x, arrow pointing that way, so smaller than -9, or x greater than 10. Alternatively, you write an inequality for interval notation. You just inequality notation from -infinity to -9. The question wasn't included, so it will not be included. Or from 10 to +infinity. Then we also had question 2.1.4, where it is x minus 7 square root x is equal to -12. So hopefully you did see that there was a change different from the notes that it has to have the equal sign in. What is our goal here? Our goal is to isolate the square root x, right? Yes, the 7 will also stay with it, but we need to isolate that because what we learned from our first question, when we had the third in the first question, we had wanted to square it to get rid of the third. That's my same goal here, which means I need to isolate the square root, meaning have it alone. But then for me to make the signs work for me, I'm rather going to say, let's take this to this side and bring this negative 12 to this side, which means I'm going to end up with x plus 12, and then it will be positive 7 square root x. That tells me I can now square both sides, and I'm going to keep the 7 there. I'm not going to have the 7 bug me, because you can still square the 7. Do not try and divide with the 7, because then you're going to sit with fractions, and we don't want fractions. So here I'm going to multiply out x squared plus 24x plus 144 is equal to 7 squared is 49, and then x and the square root cancel each other out. The square root and the square, so it's just x. Because it is a quadratic equation, it needs to equate 0, which means I'm going to bring this to this side, which means I need to minus my 49x, and that leaves me with negative 25x plus 144 is equal to 0. We do have factors for this, so it will be 16 and 9. Signs are the same, both negative, so it will be x minus 16 and x minus 9 is equal to 0, which leaves me with x is equal to 16 or x is equal to 9. The last step in this specific question would be that we need to go and test both of these two questions and see if left-hand side is equal to right-hand side. So I go now and I say 16 minus 7 square root 16, that equals negative 12, so 16 works. Then we do the same, 9 minus 7 square root 9, and that still gives me negative 12, so both of these answers work. Right. Move along to 2.2. 2.2. 2x minus y is equal to 2. That is my one equation. And then simultaneously, I need to also solve xy is equal to 4. So this time I don't have a linear and a quadratic, but I still have my linear, and then this one has a different situation. So I'm not going to try and make x or y the subject in this one, because it will then sit with fractions. And we're trying to avoid fractions as far as possible, even though we should learn to be comfortable with them. We don't have an issue with them, but I know for a fact that we're trying to avoid it because you guys are more comfortable without them. So what I want to do here is I want to make something the subject, either x or either y. My suggestion is let's make y the subject, because there's no coefficient in front of it, the y. Or there is, it's the invisible one, but it is easier than having to divide now with 2. So the y goes to the other side, becomes a positive y, and I will rather bring this to this side, 2x minus 2. What I will do next is I now know that y is equal to this, and every single time I see a y, I will replace it in brackets and substitute the value for y. So I've got x bracket 2x minus 2 is equal to 4. And to multiply out, that gives me 2x squared minus 2x is equal to 4. And what did we learn? It needs to be equal to 0. So 2x squared minus 2x minus 4 is equal to 0. And what I've learned from my trinomials, when I want to factorize, I must first take out a common factor, so I can divide by 2. Well, we will just divide with the common factor. We can take it out. If we do take it out, we will sit with this. But that, in fact, we will just divide by 2 on both sides, and it will still disappear. Right? So we've got x squared minus x minus 2 is equal to 0. So that is now its standard form, which means I need to now factorize, and my factors will be x minus 2 and x plus 1 is equal to 0, which leaves me with x is 2 or x is negative 1. My sum is not finished because we only calculated x, and the question is asking us to calculate and solve x and y. which means I now need to go and take this value back to this equation and substitute x is 2 in. So y is equal to 2 bracket 2 minus 2. That gives me 4 minus 2, which is then just 2. Or y is equal to 2 negative 1 minus 2. That's negative 2, negative 2. And then y will be negative 4. All right, let that simmer in for a moment. So it's the very similar stuff that we are doing as in question 1. We're doing it in question 2. But you need to make sure you get these basic routine questions correct. Then we also gave you a exponential question where the question is 2 times 5 to the power of n minus 2, sorry, not 2, my apologies, 5 to the power of n plus 1 plus 5 to the power of n plus 2. So this is my question. It is asking us, show that this is even for all positive integer values of n. Right, so basically positive integer, and it is even. The emphasis is on the fact that it must be even. So even numbers are 2, are 4, are 6. We call those our even numbers. So how do I go about? The first thing that I want to do is realize that we can split this up. Remember, we've learned that 5 to the power of n plus 1 can also be written as 5 to the power of n times with 5 to the power of 1. Right? Whether you write like this or you write times, it's the same thing. But why can I write it like this? Because when we have the same base, our exponents add. And that is what I'm going to do in my next step. I'm going to separate this stuff. So it will be 5 to the power of n times 5 to the power of 1 plus 5 to the power of n times 5 to the power of 2. The reason why I wanted to do that was so that I can see that there is a common factor in all three terms. And I'm going to take out my common factor, and I'm left with 2 minus 5 plus 5 to the power of 2, which is then 25. So just to make sure that 5 to the power of n was taken out, so it's 5 to the power of 2, which gives me 25. When I add this up, I get 22. What I'm going to do is to give them as a proof to why my question will always be even, or my answer will always be even, is when I do take out a 2 here, I'm going to split this 22 up into 2 times 11. And remember, the order in which you multiply doesn't matter. If I say 2 times 11 times 5 to the power of n, I'm going to do a test now. I'm going to show you. If I make n a positive 1, remember it has to be an integer. It could also be, yeah, it has to be this. So if I have 5 to the power of 1, and as they say specifically positive integers, that's why it can't be negative 1. So positive 1 now. That gives me 5 times 11 gives me 55. Right, 55 is an uneven number, but the moment I multiply it with 2, I will get 110. Right? So clearly the answer ends up in an even number. We can test another one. Let's make it 2. So 5 to the power of 2 is 25. 25 times 11 gives me 100 and 250. My apologies. 25 times 11. Sorry, 275. Having a little of a blonde moment there. So 275. And since we have 275, then if I multiply that, because that's again an uneven number, if I multiply that with 2, then I will have 550, which is an even number. 0, 2, 6, so 0, 2, 4, 6, and 8 are all my, if it ends with that, it's an even number. So the conclusion that we can make is the moment I multiply over 2, which is an even number, so the moment I multiply with an even number, the answer will end up in an even number. So this is explanation enough. Or alternatively, you could have ended in the conclusion saying that any integer multiplied with an even number will be even. Right, so you can write that also as a conclusion. Okay, great class. We've completed question 2 as well now. Right, so looking at our time allocation that we've got left, I'm only going to be doing certain questions. So I'm going to fast track it, us through a few questions. So I'm going to give you specific time limits. I'm first going to go here. Just that you can have an overall, we do have question 3. We're going to start by doing something of question 3, but we were planning on doing the entire question 3, which will not be possible due to time constraints. But you have it in your notes, and my suggestion to you would be go and do question 3, because again, it is good practice, and you can see the same type of questions appears and what must happen to that specific question so that it becomes a normal routine. The moment you read something, that you're familiar with it and you know what to do. Same question 4, question 5, and question 6 and 7. So you have it in your notes. So we are going to start off by question 3. I'm going to ask you, I'm going to change the timer. I'm going to give you so long as a head start. We are only going to focus on question 3.2. Right, the entire question 3.2. So 3.2.1 and 3.2.2. But since it is 6 marks, I'm only going to give you 5 minutes for. So you can start so long while I change my timer, and then it will end up being around about 6 or 7 minutes in total that I give you. So 3.2 is what we are looking at. We're going to copy this timer. Right. So just summarizing again, 3.2, and you will have 5 minutes to complete. Good luck. Okay, great, Charles. So let us quickly look at that question. So they've given this part to us and they said we need to solve A. So A is currently at my denominator as well as normal level. I cannot have A in my denominator, so I want to get rid of it in my denominator, which means I'm going to multiply throughout with A. It's going to be our quickest route. So we want to get rid of A in the denominator and multiply each term with A. So which gives me A squared plus just 64 is equal to 16A. And then I realize it's quadratic, which means it needs to equate to 0. And I put it in standard form, so it's negative 16A plus 64 is equal to 0. Then I'm going to go about of factorizing, which means it will be the factors of 8 and 8, which means it's A minus 8, and it will be another A minus 8, which technically gives me A minus 8 squared is equal to 0, right? Which means our only answer for A will be positive 8. Only one answer. We were supposed to only have one because remember, we only had A to the power of 1. But we made it a square and we caused it to be two answers, but it is only one answer. Right, so that will be for the first part. Then the second question, they say, just want to open up the question in front of me. They say that hence solve for x if you have this. The fact that they tell you hence, that is your guide to know that you are going to use your previous answer to solve the second question. Right? And I will show you where we're going to use it. The first part that I want to see is, I can see, I need to try now find, I just want to write down that question before I start. 6 minus x is equal to 16. If I want to need to use my previous question's answer, I need to try and compare these two questions. What I can already see is that I've got a 16 and I've got a 16. So that part is sorted. Let's see if we look more into inspection here. I can break this thing up into 2 to the power 6 times with 2 to the power of negative x. But I can't have a negative exponent. So that means that will have to go into a denominator, which means that I can rather write this part as 2 to the power 6 over 2 to the power of x. Then it is a positive exponent, right? That we're getting somewhere, But we do know what the value is of 2 to the power of 6. So we've got 2 to the power 6, sorry, that must be a plus, is equal to 64 over 2 to the power of x is equal to 16. And what I see now is how can I see and compare these things? We've got a here, but we've got 2 to the power of x here. We've got 64, so those things are there. And then it's again a is equal to 16. So what I'm gathering here is that a is technically 2 to the power of x. That is the conclusion that you need to make. And that is why they said hence. But didn't we just now, from our previous question, learn that a was 8? So instead of writing a, we are going to write it will be 2 to the power of x. So it will be 2 to the power of x is equal to 8. And then we know from grade 8 already that 8 will be 2 to the power of 3, which gives us x is equal to 3. Right. So that was question 3.2. Let us look at what question do I specifically want you to do next. Go back to the PowerPoint. The next one that I want you to do is question 6.1.4. I'm going to fast track quickly to 6.1.4. So I will do that and then I will come back to other questions just now. So I want us to do question 6.1.4. It already only has a 5-minute timer. So it's a 5 more questions. So which means I will give you 5 minutes to complete question 6.1.4. Thank you, great class. All right, great class. We had 5 minutes. Let's take a look see at our answer. Right, so we've got our exponential equation. It is important for us to note some of the following features. So you should be able to distinguish between what type of exponential equation. I can tell you now beforehand that this will be a triangle, not based on the fact that the 21 is on the side, because I see 1, 2, 3 terms. That's not the reason why I'm saying it's a triangle. Because I could have also added that on that other side, and then you would have had to figure it out still. If you look at this, one would want to think you can take out 3 to the power of x. If I look at it, if that part was on the other side, you would want to think you need to take out a common factor, but it's not that. How do I decide whether it is a trinomial or common factors? I need to go and look at my middle term. I need to look at the lowest one here. If I take the 3 to the power of x, and if I square that, remember when you square, that means your exponents needs to multiply. That will give me 3 to the power of 2x. And that I can see it resembles here, which means that if I choose to make 3 to the power of x into a variable that is easier for me now, that I choose k. Normally we use it the k method. So we normally do use k. If I choose to make 3 to the power of xk, and I then choose to square the one side, so that will be this side that is now squared. I can't just square one side, I also need to square the other side, which means that k squared will then be equal to 3 to the power of 2x. Then I can rewrite this equation that I technically have k squared minus 10k plus 21 is equal to 0. And this is the trick that I can use to make the equation look much easier for me. Because now it looks like it's just plain old normal trinomial. That I can now factorize. The factors will be 7 and 3. Signs are the same, both negative. So it will be k minus 7 and k minus 3 is equal to 0. Then I know my answers will be k is equal to 7 or k is equal to 3. What must I do next? Now I need to go and determine my answers. So I'm going to first focus, well, the question doesn't start off with k. The question started off with x and 3 to the power of x. But remember, we made it k. So if we make it that, we also need to turn it back. Which means I need to rewrite this now as 3 to the power of x is equal to 7, or 3 to the power of x is equal to 3. I'm going to start off with the easy one, which is this one. As both 3. This is 3 to the power of 1. If the bases are the same, then bring down the exponents. X will be 1. But then I need to turn to the first one. Now this one is a trickier one. It's not one that we are normally used to because the bases are not the same. But in term 1, you should have done inverse functions by now, which means that we worked with logs. And this is where I'm going to turn to. Remember, how do I go about to go and fill in my log? We write it out as exponent is equal to log, then it's the base, and then the subject. So if I follow this process, then what was my exponent in this case? My exponent here was x. So I will write x is equal to log, according to that, my base was 3 and my subject was 7. And the moment I now, well, you can't do this out of your head. You have to use a calculator. On your calculator, you've got a normal log, but that's not the one that we want to use. We want to use the one with the blocks. So log 3, function 3, we've got 7. Type it in, and we get that the answer will then be 1,77. So they're trying to trick us in this question a little bit. that we had to go and figure out how do I then solve this and use our log knowledge to complete this. Right. So we are going to do another question. I want us to go back now to the notes. So the next question that I want you to complete will be question 5.1.4. Again, our timer is incorrect. So we are not going to do both those circled ones. We are going to do only question 5.1.4, right? And I'm going to give you 5 minutes to complete because it's 4 marks. I'm going to give you 5 minutes to complete 5.1. And that will be on page 3 and 4 of your notes. So just check there. You've got 5 minutes. Good luck. Okay, grade 12, we are going to look at our answer. Right. If I look at 5.1.4, again, it's the one of the third, which means that, again, I need to be able to square to get rid of the square root. But that means I want to isolate the scenario, which means I need to get rid of this plus 2. It needs to go over to the other side. So I've got 2 square root x plus 6 is equal to x minus 2. Right? To get rid of the square root, we've learned that we need to square. What I do on the one side, I do on the this side. That means that I now have 2 that is to the power of 2, which gives me 4. But then what must I do with this now? Because the square root and the square cancels each other out, but then I've got x plus 6. Do I just write x plus 6? No, it is bracket x plus 6, because this, the answers needs to multiply with one another. It's like there's a times there. Right? Is equal to x squared minus 4x plus 4. We know that one now. Then it is my job that I need to now go and multiply out here. So it is 4x plus 24 is equal to x squared minus 4x plus 4. And it's an x squared, and we learned when it's a quadratic equation, it means that it needs to equate to 0. So I've got equal 0 equal x squared, and bring the 4x over, it becomes minus 4, so it's minus 8x, minus 24 now, so it's minus 20 or negative 20. Then I can factorize my trinomial, and it will be 10 and 2. Signs are different, biggest one negative, so it will be x minus 10, x plus 2, which gives me x is equal to 10, or x is equal to negative 2. Remember what I said? We need to test our answers. If we test our answers, then we're going to realize that this one does not equal, right? So we are going to end up drawing a line through that one and say it is not applicable. It's only the 10 that works. Right. We do have time, grade 10s. Oh, grade 10s, grade 12s, my apologies. We do have time for one more. So what I want us to do is I want us to go and look at question 7.1.3. Right, so you've got 5 minutes, which starts now. That is on page 4, question 7.1.3. It's another inequality. I quickly want to look at that last one. All right, good class. I'm going to have to start so that we can finish on time. So if I look at this one, very importantly, you cannot have in an inequality. I know we normally take everything to this side because we want to keep it, or normal equation, we want to keep it positive. But by inequalities, it must always have the greater than sign and 0 on this side. So we'll have to take this to this side and we'll sort out that negative just now. So if we put it somewhere in standard form or in the right order, actually not standard form yet, plus 5x plus 4. Now I want to put it in standard form, which means I need to get rid of that negative. Once I do that, I take out a negative, which gives me 6x squared minus 5x minus 4. But I want to now get rid of this negative because I can't try and factorize with that negative that is stuck there. So what I will now have to do is, we learned, I think it was in our first question that we learned that if I do divide with that negative, our inequality is going to swap around. So I've got 6x squared minus 5x minus 4. But now, instead of being greater than, it will now be less than 0, right? And because it's now less than 0, now I am ready to factorize my trinomial. I almost forgot my square. Which means now my factors will be, I'm going to just factorize it for you just to save time. 3x minus 4, and it will be 2x plus 1, smaller than 0. Right, now we need to look at our critical points. So we've got our critical points being negative a half for this one. So negative a half. And our next critical point will then be 4 over 3. Remember our parabola? There's our parabola. But this time, and this is why I wanted to quickly add in this question. If it says less than, it means we are actually looking for what is below 0, which means it's negative numbers. So where is my y values? Negative. And that means I'm looking at this section here, right? And it's only one times that I highlighted, which means it's only one answer. And then how do I write this answer in my two notations that we know? In inequality notation, our x will lie between the values negative a half and 4 over 3. But because it lies between, it will always, always, always have this arrows pointing this way, right? Or you can write it, and this time I find the interval notation more easier to say, because I know you guys mess up this sign. Either you write it like this or you write it like this. Doesn't work, right? Or sometimes you just write it like this as well. It has to be both the same way, because it says negative half is smaller than x, but x is smaller than 4 over 3. But then this is why I then prefer, when there's only one answer, to write it in interval notation, right? Where you then have from negative a half to 4 over 3 is my answer. Was it included? No. So then it's going to be round brackets by both. That's it. So it's easier then to write it in interval notation. All right, grade 12, we really did a lot of work today. I'm just going to show my face again. And I just would like to say thank you very much for all your hard work. And the fact that you are here today and that you put in the effort, because I really know that it's going to give you the good outcome that you want and you desire. So I'm looking forward to seeing you tomorrow again, and then tomorrow we will be looking at functions. You guys must have a great day further, and see you tomorrow. Thank you.